This is 2016, number 3. It's a non-calculator question. And you'll notice that we have a graph here, and it happens to be another curve sketching problem. So it says, the figure above shows the graph of a piecewise linear function. All that means is that we have a bunch of different pieces that are kind of glued together to make a function together. It says for -4 to 12, the function g is defined by g of x equals the integral from 2 to x of f of t dt. Again, you may not know what an integral means yet. All right, we'll get to that second semester. But to kind of allow you to do some of the parts of this problem without knowing what an integral is, let me tell you the relationship one more time. So remember that an integral is the opposite of a derivative. So taking the integral of f of t and getting a different function called g of x is like saying that the function f of t is the first derivative and g of x was the original function. So let's make ourselves a little note that it's pretty much just saying that g prime of x or g prime of x is equal to f of t. That's pretty much all that this means. All right, so the integral is helping us to build that relationship that if I take the derivative of g, I should get f, which means if this is a graph of f, that this is g prime of x. So when you look at this graph, you should see a graph of the first derivative is all that that's pretty much trying to tell you. It says, does g have a relative minimum, a relative maximum, or neither at x equals 10, and justify your answer? Well, if this is the first derivative, remember that to find a relative min or max, I'm looking for zeros of the first derivative. So I have a 0 here, a 0 here, a 0 here, and a 0 here. So 10 is definitely a possibility of having a min or a max. However, notice that it does not cross through the x-axis. It touches it and then comes back down again. It bounces off the x-axis. In this case, that means on the original function, 10 would be a horizontal tangent line, but it would not actually be a maximum or a minimum because it goes from negative y values to negative y values on the first derivative. So the original function would go from decreasing to decreasing. So we're going to say, no, g does not have an extrema at x equals 10. Because even though x equals 10 is a 0 of g prime, it does not change sign. And again, I will over-explain here for a minute. Therefore, the graph of g of x is decreasing on both sides of x equals 10. So, for part A, no, it is not a relative, oh sorry, that was kind of cut off. No, it is not a relative maximum or a minimum because even though it's a 0, it doesn't change sign, therefore it is not a high point or a low point. That's worth 1 point. Part B, does the graph of g have a point of inflection at x equals 4? Remember that points of inflection on the original function look like maximums and minimums on the first derivative. So here's x equals 4. Oh, yep, that's a maximum, so yes, it is a point of inflection. So for part B, we'll say yes, g has a point of inflection at x equals 4 because, again, these justifications are so important. It has a point of inflection at x equals 4 because x equals 4 is a relative maximum on g prime of x. And again, I will save you from that over explanation, and that is worth 1 point. The other two parts of this problem you actually are not able to do. So finding an absolute minimum value and an absolute maximum value of g, you would need to know how to find the integral. So we can't do that part yet. And then for this interval, find all intervals where the original function is less than or equal to 0. Again, we won't be able to do that part yet, so we'll leave those until later.